Today we are doing section 4.4, the Pythagorean theorem and distance formula. Our objective is to find side lengths of triangles and distance between points. Alright, we've got a couple new vocab words today. We are talking about the word legs again, but this time it's in reference to right triangles. They are the sides that form the right angle. So I'm going to sketch a little diagram here. If this is my right triangle, I'm going to label the sides A, B, and C. A and B would be considered my legs. Those are the two that meet to form the right angle of a right triangle. The hypotenuse is the side across from the right angle. So in this case that is C. So side C is my hypotenuse. The Pythagorean theorem is something that you've probably seen before, written out in words. It's a little lengthy, but you might want to make a note by it that given a right triangle labeled with sides A, B, and C, C is the hypotenuse, we use the formula A squared plus B squared equals C squared. So I would definitely make that note and have a diagram of a right triangle in your notes. The last thing on this slide we should have gotten written down on the last page of the notes. We will work with that in a minute. That is the distance formula. We already talked about distance between a couple points in the warm-ups. However, those points were either on a vertical or horizontal line. So if we are given points where either the x or the y coordinates don't match each other, we can use this formula. The distance is equal to the square root of the difference of the x values squared plus the difference of the y values squared. We're just going to plug our points into that formula and do a bunch of calculations. Alright, on this slide we've got another reminder. The Pythagorean theorem states that the hypotenuse squared is equal to the side lengths of the legs squared added together. So we're going to use that on these problems. On these problems we are asked to find the hypotenuse every time. I believe on the next set of problems we will be asked to find the length of a leg. If we have legs, one of them is A, the other one's B. It doesn't matter which is which. So I'm going to say that my A has a length of 10 and my B has a length of 24. We are trying to find C, the hypotenuse. So we set up the formula that we just talked about. And for A, I'm going to plug 10. For B, I plug in 24. And C, I don't know, so I'm just going to leave it as C. All three of those things are squared. 10 squared plus 24 squared equals C squared. Now I just have to start doing some computation. A calculator is probably going to be handy during this lesson. 10 squared isn't so bad. What's that? 100. Plus 24 squared is probably one not many people have memorized. It is 576. And then we have to add those together. What do we get? 676 equals C squared. But we are not finished with that. How are we going to get C by itself? Dividing both sides isn't going to help. Dividing does not undo squaring. Square root both sides. That is what is going to undo squaring. We square root both sides. That's going to make sure that C is by itself. But that means we have to simplify the square root of 676. This is why we did a whole week on radicals before we did this chapter. What can I divide into 676?
One of them going to be 26. I'm still finding out the number. Like 6 times 26, we lead a column down number.
So I like the idea of using 26. 26 times what?
26.
Times 26. So do I need to keep going? No, this is a perfect square number. We have a pair. So the square root of 676 is just 26. Now, it's not always going to work out that nice, but luckily this time it did. So this is our answer. C equals 26. All right, on the next one, again, I'm looking for side C. I always like to go through and label my A and my B. In this case, they're both the same number anyway. So when I plug into this formula, both A and B turn into 7s. 7 squared plus 7 squared equals C squared. 49 plus 49 equals C squared. What's 49 plus 49? But what do I still have to do to get C by itself? Square root it. When I square root 98, is that a perfect square number? No, it is not. So that means I am going to need a factor tree. I'll erase my last one. What can I break 98 into? Jaden? 49 and 2. 49 breaks into 7 times 7. We've got a pair of 7s, so that means that the square root of 98 simplifies to be what? 7 square root 2. So C is equal to 7 square root 2. So like I was saying earlier on that first slide with the warm-ups, from here on out, if you were to give me a decimal answer here, I would get marked wrong. If we were doing partial credit and you showed some work, you could still earn some points there, but your final answer will only be marked correct if it is a simplified radical, not a rounded decimal. All right, I want you to try the last one, and then we will go over it together in just a moment. Wonderful. Our initial equation should be 14 squared plus 9 squared equals C squared. If you had 9 squared first and 14 squared second on this problem, that's fine. It'll be just fine in the end. Somebody new, tell me what I get when I take 14 squared. David. 196. And what about 9 squared, David? 81. IKEA, what do I get when I add those together? $277. Is 277 a perfect square number? Anybody? No, it's not. So that means we are going to have to try to simplify it. Is there anything that we can find that will divide into 277? All right, so this one does not simplify. So when we square root both sides, we are left with a final answer of C equals the square root of 277. If it doesn't simplify, you just leave it there. On these ones, it is extra important that we label our sides correctly. On the last ones, A and B could go on either side because they're both legs. But C, the hypotenuse, has to go on a certain side. It has to be the one across from the right angle. So on number 4, which side should I label as C? 23. They're asking for B, so that means this other side must be A. Let's just go through and label all of them before we get started. On number 5, which side has to be C? 11.9 has to be C. They're asking for A, so B must be the other side. On number 6, which side has to be C? 26. They labeled the other one A, so B is 24. Now this might be something you already noticed, might be something you already knew. The hypotenuse is always, always, always the longest side. The hypotenuse will always be the longest side of a right triangle. Okay, so let's set up an equation for number 4. So remember, if you want to write it above, to refer back to it, we can. I need a new volunteer to set up my equation. Somebody I have not heard from yet today. We labeled all of our sides. We plugged in what we knew for A. We didn't know B this time. We plugged in what we knew for C. We evaluated the squared numbers that we could. Now to get B squared by itself, Quentin, what am I going to do?
Don't you have to divide those two numbers?
I am not.
Oh.
John,
Subtract 121 from 529.
I have to subtract 121 from both sides. That leaves me with B squared equals 408. Is that a perfect square number? The answer is no, it's not a perfect square number. So when I square root both sides, I have to see if I can simplify this. So we take 408. If you want, you can start off with the number 2. 2 will always divide into something. Or you could start with the number 4.
I used 8.
Or 8. What did you get when you used 8?
51.
8 times 51. 51 can break down, but not into anything useful. That'll be 3 and 17. Well, 8 will break down into what?
2 and 4, and then 2.
2 and 4. That 4 breaks into 2 and 2. We only have one pair. It's the 2's. So we have 2 square root. We multiply these other numbers back together. 3 times 17 is 51, times 2 is 102. So we end up with 2 times the square root of 102. What was different about this problem is that we had to subtract a leg squared from the hypotenuse squared before we square root it. So it will change when we're finding a leg instead of the hypotenuse. Very good. A squared plus 24 squared equals 26 squared. We don't know A. We labeled B and C. We plugged those in. Now from a previous problem, we might already remember or know what 24 squared is. 576. And what is 26 squared? 676. This might look familiar from a problem we just did, but now we want A to be by itself. So what do I need to do? Subtract. When I subtract 576, I get A squared equals 100. How do I get A all by itself? Square root both sides. A equals 10. So you can just write on number 5 that we skipped it. We can set it up, we can do it. It's not going to come out nice because they gave us decimals. So doing square roots with decimals just gets ugly. So so we'll skip that one for now. All right, the next thing in our notes is Pythagorean triples. Pythagorean triples are integer triples that satisfy the Pythagorean theorem. So 3 integers that satisfy the Pythagorean theorem, meaning we don't have a radical left. There are no radicals involved. All 3 numbers are integers. One example we just saw. What was the last problem? What were the side lengths? The last example we just did, what were the 3 side lengths? 10, 24, and 26. That's an example of a Pythagorean triple. The most common one that you'll see is 3, 4, 5. Okay, 3 squared is 9, 4 squared is 16. If we add those, we get 25. The square root of that is 5. So 3 squared plus 4 squared equals 5 squared. There are other ones that we'll come across. So these are the ones that are all 3 numbers are integers. We don't have to do any simplifying of radicals. They're all perfect square numbers when we square them. All right, we are going to stop notes there. We will finish them off and do distance formula tomorrow.